Hi guys, so this is the reminder video that I was telling you about for exponential functions. So tomorrow when we start your STEM project, you're going to need this little bit of a review just about exponentials that hopefully you guys remember from last year. So looking right here, so this exponential function y equals a times b to the x. So an exponential is the function that has a variable in the exponent, okay? So there's some key components that you need to kind of know about. So this y is your final value. A is your initial value, basically what you start with. B here is your base, and I like to think of it as how you change, okay? And then this x is your exponent. It is always going to be time. Okay, so exponential functions, you can have exponential growth and you can have exponential decay. And this is just a reminder over here. If you have y equals a times b to the x, if your base is bigger than 1, it's going to be growth. Because basically what you're doing is, if your base is bigger than 1, say a 2, let's say you had y equals 2 to the x. Let me write that. And you plug in a 5 here for x, you would have 2 to the 5th power, which is 2 times 2 times 2 times 2. Exponentials are repeated multiplication, basically. Okay, so if this number, what the exponent is attached to is bigger than 1, it's growth, and it's going to take this shape here. And then decay, if your base is between 0 and 1, notice it's not just less than 1, it's between 0 and 1, it's going to be decay. It would start bigger and get smaller. So that might be like multiplying by a half, like teams being eliminated. If you had 64 teams and 1/2 are eliminated, you would multiply by 1/2 every time. Another way we see that too is like with percents. So something that you guys need to see, and I don't have it up here for you, is sometimes this base here, so words that you could have for your base, so I'm just going to write base words. So you might see words like double, triple, half, half-life, things like that, okay? Sometimes, though, you may increase or decrease by a percent. And I don't know if you guys remember or not, but if you increase, whoops, if you increase or decrease by a percent, that B, I don't know what I clicked, that B is going to change and become y equals a times 1 plus or minus r to the x power. All right, so if you increase by a percent, it would be plus. If you decrease by a percent, it would be minus. A lot of times, this is used for populations, appreciation, meaning an increase in value, depreciation, a decrease in value, like the value of a car. So the car value over time is going to depreciate, meaning go down by a percent. And all that means is when something increases by a percent, it's not going to be a constant amount every time, because the percent, 10% of 100 is 10. So if I had 100 and I add 10%, I would have 110. And then if I take that 110 and add 10% more to that, it's going to be $11 would be added this time. So instead of adding 10 again, it's $11. So you have to consider the percents there. So using these two equations up here is what I want you guys to think about. And really tomorrow in class, we're going to be focusing more on percents, and we're going to be looking at populations and our disease, or our the spread of a virus. So coming down here, so we're just going to start writing some equations and solving them, okay? So the number of flowers in Sally's garden are doubling every day. She started with 2 flowers. All right, so there's keywords, I underlined them, doubling and started with 2. So if we were to write the equation, all right, so f of x equals, she started with 2 and she doubles. So we would have 2, because she started with 2 flowers, And every day that is going to double or multiply by 2. So if you remember, based on up here what we said, a times b to the x, because there's no percent there, so it has to be a times b to the x. A is what you start with, b is how you change, and it doubles, so that's times 2. How many flowers will she have in 7 days? Well, that means plug in a 7. So you get 2 times 2 to the 7th power. Okay, so if you have a calculator, you could plug that in. 2 times 2 to the 7th is 256 flowers. I guess we should write that. Okay. All right, so number 2. So now we're getting into some population. So the population of Smallville was 1,112 in 2000. The population was increasing at a rate of 26% each year. Increasing at a percent. So that means my base is going to be 1 plus r, whatever that percent was. Okay, because it's not saying doubling or tripling. So we can write the equation. We start with 1,112, and we're going to multiply by 1 plus r. Well, the percent was 26, and we don't write 26%. We would write 0.26 to the x power. So then we would combine. That would give you 1.26 to the x. And if the population is increasing, we know it's growth, so we know that this final base right here needs to be bigger than 1. 1.26, it's increasing, it's bigger than 1, so that's good. How many people could be expected in Smallville in 2020? Well, this started in 2000, and from 2000 to 2020 is 20 years time, right? So you're just going to plug in a 20. 1,112 times 1.26 to the 20th power. Okay, so we plug that in, 1,112 times 1.26 to the 20th power. And we're going to get 1, 1, 3, 1, 1, 3.8, and we know it's people, so we're going to round to a 4. Okay. So an ant mound starts with 105 ants. The population is increasing 8% each day. Again, increasing, that's telling me my base is 1 plus r here. Okay. All right, so can we write the equation again? So I'm starting with 105, increasing 1 plus the percent. Well, 8% as a decimal, you move it 1, 2 to the left is 0.08 to the x power. Okay, so that is f of x equals 105 times 1.08 to the x power. There's your equation to model the increasing population. The population started with 105, increases 8%. Increasing, it's bigger than 1, and it's increasing by 8%. So how many will there be in 12 days? So f of 12 is 105 times 1.08 to the 12th power. So we get 264 ants. Okay. So one more, and then I'm going to let you guys do the rest, and we'll check them in class tomorrow. The population in Williamston is decreasing. Here's a different one. Decreasing at a rate of 4% each year. So the decreasing means that my rate needs to subtract. So 1 minus r. Today there are 1,212,546 people. So can we write the equation there? So we start with 1,212,546 times 1 minus this time 0.04 to the x. Okay, and then we reduce. So f of x equals, move this guy over here, 1,212,546 times 1 minus 0.04 is 0.96 to the x. Okay, so let's look. 0.96 is less than 1, so that means decay, which this is decreasing, so it should be decay. 0.96, when you compare it back to 1, It's 0.04 less than 1, so it's showing this the 4% decrease. So if you decrease by 4%, you're maintaining 96% of something. That's where that number comes from. So then we plug in. So how many people will there be in 5 years? So f of 5 is 1,212,546 times 0.96 to the 5th. And let me plug that in really quickly. And we get 988,677 people, and we round to the nearest whole number because we're talking about people. Okay, so I want, using what we just did right here, you guys do the backside. So increasing, depreciates, loses its rate, increases. I think you guys can handle these, okay? So 7 and 8, you're going to write it and solve it all in one, okay? So here are these answers again. If you need to rewind and go back at any point, please do that. Just make sure that you guys get these problems done and the back of the worksheet done so that we can go over it in class tomorrow. See you later.